Okay. This is the second chapter, how time and interest affect the money. Remember, in chapter 1, we've talked about the factors and the framework of the engineering economics. And we mentioned 3 things: time, money, with interest. So those 2, time and money and interest, how they are going to affect the money. We have different cash flows. We'll see them all now one by one over those 2 weeks, starting from today's lecture. So the objective here to derive and use the engineering economy factors. Engineering economy factors to account for the time value of money. So we have different factors. What are those factors? What are those cash flows? And remember, different cash flows. Not only one type like what we did in previous chapter for only calculating the P or calculating the F, the future. No, we can have many of them in one cash flows. How to combine them together, we'll see in this chapter in addition to chapter 3. So the first thing, single payment. Notice how we are going to read this. Very important to read it as what is written there. The first one, this is F given P. F given P. What does it mean? Want to calculate the F, this is unknown. P is given. And here, P giving F. So want to calculate that P giving this F. Later on, I don't want any one of you, because we are going to use those as a standard in our standard notation. Standard notation. We're going to use them as they are in front of us here. So later on, I don't want any one of you to write, for example, F divided by P. To tell me that F given P. No. Use that notation as it is. Or some of the students, that what we saw in previous semesters, they are putting it like that, F dash P. And at the end, they were confused with that. They are subtracting the P from the F. Don't use it. Don't do those 2. Just stick to what we have in here. So what we're going to cover today's lecture, inshallah, only the first section here for a single payment, like what we did in the previous chapter, but to find the F giving P, the P giving F. Just a single payment from the word here, single payment. i.e., we're going to see it only once. The calculation for that single payment will be only once, to bring it to future, or from future to bring it to present. Then we'll see the other sections. Present worth. This is a common lecture. Present worth P given A, and capital recovery A given P. What does it mean? P giving A. Want to calculate the P, the present worth, the equivalent present worth for the annuity that what we're going to have in the future. Want to bring all of them to time 0 or whatever time in front to the left of that annuity. Capital recovery. The second one, A given P. A, want to calculate A for a given P, like what we did for a single payment. What about if we take a loan? If you took a loan from a bank, that loan need to be recovered, i.e. to pay for that capital, for that principal. The P here is the capital or the principal. Want to return it back in installments, بالأقساط, بالتقسيط. So how much then will be that installments, which is the annuity. That's what we call capital recovery. Sinking fund. A given F. A giving F. In future, want to reach to certain amount. Say, for example, you want to have 10,000 BD after 5 years. How much to put yearly in a bank, in a saving account, to reach to that amount, knowing a certain interest rate that paid for that investment. So how much to put per year? Did the sinking fund. And finally, a uniform series. F giving A. F giving A, which means what? How much we are going to have in the future if we are going to put this much per year. Always those two, P given A given P, A given F given A, or here F given P or P given F. It's just that, vice versa. So the same calculation, but in other direction. Later, we're going to see those two. Each one of them in a lecture. The arithmetic gradient and the last one, geometric gradient. What do you mean by those arithmetic and geometric? Especially here, P given G, A given G, F given a G, whatever. But with capital G, that G representing that arithmetic gradient. Capital G representing arithmetic gradient. But do we have anything for that geometric gradient? We'll see it later on, inshallah, because that will have small g, but that g will not be in this notation. We'll use something else. What we are doing here now, let us see it now as, for example, in this example here, what do we have in here? To combine all what we said earlier, to find a single payment for F given P or P given F, represent what for P given A or A given P. Notice what do we have? Because later on, we are going to combine all what we have in one cash flow diagram. A shifted cash flow diagram. We'll see what do you mean by shifting. This in chapter 3. So if you know how to solve this later on, inshallah, it means you know how to solve any problem later on. This is chapter 2 and chapter 3 both together in this example or this exercise. So let's see what we have. The first part in here, that 1,200 is a single payment. It is at year 5. 1,200 at year 9. We have another at year 13, 950. That's upward and here downward. So those 1,200 in year 5 and 9, positive. Why? They are coming to us. But 950, we are paying that. At year 15, 6,800, something called salvage value. We'll see what do you mean by salvage value once we come to it. See the annuity to find P given A or F given A for that annuity, which started from year 8 to year 15. Did the annuity. We'll see what to do with it. We have another thing, that the arithmetic gradient. Notice here it was 500, but it's increasing starting from the first cash flow here in year 2 up to year 7. It's increasing, but upward, it's fine, it's not a problem. It's a straight line. We have another arithmetic gradient downward there, but that one is decreasing. We can have an increasing one, but what we have here, this is decreasing by certain amount from year 1 to year 4. And finally, we have the third one, or the fourth one, which is the geometric gradient. Is decreasing or increasing by a percentage. The arithmetic gradient is increasing or decreasing by a constant amount. But for Geometric gradient is decreasing or increasing by a constant percentage. I'm not going to go through this now. Once we're done, inshallah, with the basics of chapter 2, we can solve that together. Have it in front of you. Take a capture for this, because later on, inshallah, we'll work on that one. Need you all to practice it later on to find the different requirements in here. Is that clear, Shabab? Okay. So let's start with the first, which is the single payment factor. Single payment factor, F given P and P given F. Like exactly what we did in the previous chapter to find for a single payment. And most of what we are going to do is what? Using a compound interest. That's why I told you from the beginning to understand it well. Compound interest, we are going to use it heavily throughout this course. A simple interest, it's only in the first chapter, though you need to know and distinguish between them. Okay, let's start now here. Derive factors to determine the present P or future F worth of the cash flow. The P or the F of the cash flow. What says here at the beginning? Derive. So we're going to see that derivation for it. Notice one thing also, that what we mentioned earlier, we're going to use that F given P or P given F. How to read it? Find the P for a given, find the F for a given P. Find the F giving P. And that's how we're going to write it. We can do, or we can find the other thing, which is the P. Find the P giving what? The future value. And we saw the cash flow diagram for it, CFD. If we have the P naught, we can have, or we can calculate the FN. Later on, we don't have to show this. Now we are seeing it just to tell you that this is at time 0. We can have P in here to find it at that time, or we can have it in here anytime just before that N, even here N minus 1, it's in history. It's a present for that future. Will be a present for that future. The cash flow diagram. What you need to have in there? It's a line like what we mentioned in the previous lectures. This is a line here. Each one considering as a period up to N periods. Up to N periods. If the money is out from our pocket, is downward, so this will be negative. If it's coming to us, it will be positive. The I always need to be there. We need to show the I, the interest rate, over the cash flow diagram. I'm repeating this because I don't want anyone of you to lose marks because of this. Now, let's come to derivation. How we derive a formula, like what we said in the previous chapter. For example, F equal to P 1 plus I power N. How to derive that formula? We'll see it now. The factor P given F is known as the single payment present worth factor. Single payment present worth factor. Don't worry about that. You are not required to memorize it or to remember it. What is the general formula now? How to get to that formula, which is F equal to P 1 plus I to power N. If you want to solve for this, to find the F now, that Fn after n periods is n minus 1, this period 3, period 2, period 1. How to find it at that period? Just imagine if you're going to calculate F in here at year 1, then to calculate F at year 2, F at year 3, till you reach to that period n. We're not going to do this later on, but we want to derive a formula for it. Now, let's calculate for the first. Always will be over that principal. So the principal plus principal multiplied by Li to give that future worth at tier 1. So F1 will equal to the principal plus principal multiplied by interest. So it's P multiplied by 1 plus I. This for the first year. Now if you want to calculate for the second year. For the second year, you don't have to go for this. Now you have this value just 1 year in front of you over 1 period only. Now let's calculate F2. So F2 here will equal to that F1 will be considered as the present for F2. This will be a present for that F2. So F2 will equal to F1 multiplied by 1 plus I. Always, if it is only 1 period, just multiply it by 1 plus I. Why? Because we are going to consider that F1 as the principal for that F2. And F2 is the principal for F3. F3 is the principal for F4, and so forth. Take that. After substituting for F1, so F2 will equal to 1 plus I multiplied by 1 plus I, which means what? F2 will equal to P 1 plus I squared. Do it now for F3. If you're going to do it for F3, exactly will be the same as what you did in here. Take F2 as the principal for F3. So it will be F2 multiplied by 1 plus I, which is equal to, just substitute for that F2. What do we have for F2? 1 plus I squared. The missing part in here. Just substitute there. So F3 will equal to P multiplied by 1 plus I to power 3. What can you notice in here, guys? شباب ايش قاعد او شو تشوفون هني؟ When the power here equal 1, we're talking about the first one. When the power 2, we're talking about second period. The power 3, third period. If you want to do it for Fn, this is equal to what? For Fn, what will be the power?
N.
Power n. That's exactly what we got in here. Later on, you don't have to write this. Now let's see the standard notation, how you're going to formulate the problem. How we're going to formulate the problem. We know now how to calculate the formula. We know the formulas. But we want to see how to write it. What will be the standard notation? Because as I told you before, we're not going to work only with one cash flow. We're going to have many of them, which means to combine them to show if you got, for example, a wrong answer, you're going to lose everything. That's why we're asking the student always to write the standard notation. Standard notation. What is this standard notation? How to write it? What do we have in here? F giving P. F giving P. Which means what? What we need to calculate? We want to calculate the F. We want to calculate the F. We have the P. It's given to us. So see the standard notation. How to write it? Remember the formula. Factor formula. It was F equal to P multiplied by 1 plus I to power n. Now let's see this. We have the same that what we want to calculate. This is known to us. Just right now that put in so that brackets. Want to calculate the F giving the P. Calculate the F giving P in the same order of what you have in here. Just put it in there. F equal to P. We open the bracket now. F given P. What things we have? And remember, in previous chapter, we said we need to have a 3 out of 4. 3 out of 4 terms. What are those 3? The P is given. So we need to know I, N. We need to know also I and N. So the standard notation for finding the future value giving the P, F equal to P. It will be in the same at that one there. Same sequence, F giving P. Now, if we know I, for example, equal to 5%, N equal to 3, directly substitute in here for I 5%, N 3. You don't have to write this, then substitute later. No, do it at once. If you have that value, for example, 1,000, just put it directly there. 1,000, F given P, 5%, 3. Always need to show this. Then the standard notation. A cash flow diagram. Now let me tell you the marks will be how it's going to be distributed. For example, if we are going to do the cash flow diagram, CFD, can have 2 to 3 marks for that. 2 to 3 marks for the cash flow diagram. Standard notation. 6 marks, almost 6 marks for the standard notation. So it's 5 to 6 marks. The final answer, 2 to 3 marks. Factor formula. Fn equal to P, 1 plus I to power n. Can we use this to solve using Excel? Yes, we can. What are the formulas in Excel? What will be the formulas for Excel? Exactly like what we did in here for those two. The good thing in Excel, there we have a built-in function for finance. Try to practice them. At the end of the lecture, just go for Excel, use the function or the function that I'm going to show now to work out for the coming examples. Now, if you want to calculate the future value, which is the unknown for us, you want to calculate the future value, which is unknown for us here. So FV, that's what we want to calculate. You can tell the Excel that calculate for me the FV, giving what? Giving those. I for the percentage, 5%, N, 3. Notice here, we left it blank. Just comma, or you can put 0. Why is empty? Because this is for PMT. What is that PMT? Is the annuity. We don't have annuity in our example. If there is an annuity and you want to calculate future value for it, you can do. If there is no annuity, just a future value for a present value, put the present value in there. Need you again, guys, to practice the common exercise using what we have in here. Now to find the P, giving the F, and vice versa now, in other direction. What we call it, discounting back in time. Discounting back in time. One thing to mention here also, always the F will be greater than the P. If you are going to future, always the F will be, the value of it will be more than the P. Notice one thing also here. From those two, what do we have? F, and that's F in there. P, and we have that P in there. So the factor F giving P I% N did the same thing as 1 plus I to power N. If you want to get the value for this, just substitute into that one without multiplying by P. So what we have in here between those parentheses, two brackets, is the same as what we have over that I plus or 1 plus I to power N. Because both of them will be multiplied by P. Now, finding P, giving it F. The P given F factor brings a single future sum, which is in the future, just bring it back to a specific point in time. There is no condition to bring it to time 0. It says here, to a specific point in time. It can be year 1, year 2, year 3, year 4, but to the left of the future one, which is, if you want to calculate, for example, for year 5, the present for it can be in year 4, year 3, year 2, year 1, or year 0. How to solve for that? It's the same. P equal to F multiplied by 1 divided by 1 plus I to power N, i.e. the reciprocating of what we did earlier. When we said that F equal to P 1 plus I to power N. If you want to find it for P equal to directly F divided by 1 plus I to power N, or 1 plus I to power minus N. The standard notation. Since we are going to find P given F in the same sequence, so it will be P given F I% N. I'm repeating this point again. Don't write those later on. Whenever you solve any problem, don't put them as I% and N. Just write the substitute directly. Substitute the values directly in here. 5%, 3, or whatever. That one, no one will change. No one will tell me later on P0, F3. No. The standard, don't change it. P given F. Whatever LP is, if it is P1, P2, P3, it doesn't matter. That will not be reflected inside here. It will not be reflected inside that P given F. Keep it as it is, P given F. That's why they call it standard. No one will change it. Is there an Excel function for this? Like what we did earlier for F. We said, okay, FV, then we wrote I%, and we left it blank there, and we put P here. The same idea will be applied to calculate present value. I, N, blank, F. The only thing, or that thing different now, what we want to calculate present value instead of the future value. Since the present value, so put the F. Since that one future value, put the P. Let's say an example. Now, inshallah, we'll work together using a calculator. We're going to use a calculator to solve the problems now. Read this problem. extract the information and all the data given to us. An industrial engineer received a bonus of $12,000. Okay, he received that bonus. It comes to him. That he will invest now, which means what? He received it, but he's going to invest it. He's going to invest that amount. How much is that amount? $12,000. Since it's now, so at times 0. He wants to calculate the equivalent value after 24 years. So what we have in here is N. Year 1, year 2, year 3. I'm not going to put all of them. 23, 24. The equivalent value at that year. How much will be in the future? Now, what is the interest rate? This is incomplete cash flow diagram. We need to show interest rate. It's given to us here 8%. It says per year. We know that per year or that type of interest is a compound interest by default. I'm repeating this because some of the students later on where they are going to confuse and to ask whether this a compound or a simple. By default, it's a compound interest. Find the amount he can pay down, or let me read it again here just to know why he wants to invest that money when he plans to use all the resulting money that in year 24, the resulting money, he wants to pay it down as a down payment, مقدم, on an island vacation home. Assume a rate of return of 8% per year for each of the 24 years. Find the amount he can pay down. يعني بياخذ البيزات اللي بتطلع هني بيحطها في investment. He is going to invest it in somewhere else for that vacation home. Using both the standard notation and the factor formula. Standard notation and factor formula. Now, if you what you want to calculate, بكم أنتوا تشاركوا وياي. I'm not going to see it now. Need you to say exactly how to write it. What is required from us, guys?
F given P.
No, I think the full standard notation. The full standard notation. Not only F given P. I know that, but give me the full standard notation.
F equal P.
F equal to
P.
direct substitute. 12,000.
FB.
F مو FP بس عشان نكون واضحين بعد. Given P.
ايوه 8%.
8%.
24 years.
24. هذا الستاندرد notation. Then the first part, solving any problem. Diamond, just give me the standard notation and give me the final answer. But now, how to use the final answer? For the time being, we are going to use that factor formula. What is that factor formula? So F equal to what? 12,000, the P. 1 plus أعطوني بالفورمولا
0.08
0.08
to the power 24.
Power 24. So what is the answer here?
76,094.16.
With the unit. شباب, with the unit. Be careful. بسوي تحت هنا. F equal to units. The answer, شباب.
760.
7, yes.
94.17.
Thank you. Now, طلعنا الجواب دي. want to check using a calculator, want to solve using a calculator. But again, this is the first step. The calculator will give you only this answer. Let's use your calculator together. Have it in front of you. The first thing to do, always, whenever you want to solve any problem using the calculator, if it is the first time to use it or you've used it before, the first thing, just once you press on, see the shift at the top left side, that bottom there. Press shift, then 9. Shift, then 9. What can you see now?
Set up memory and all.
فوق الستة مش مكتوب.
Clear.
Clear. So we want to clear everything from previous work on that calculator. Why? Because if you miss one of the value that you already entered for previous problem, is going to be included in the second problem or the coming problem that you are solving. So always clear that. Clearing what? Just scroll down, go to all. Scroll down, go to all. Press execute. What does it show now?
Reset all.
Reset all. Yes, execute. Now, what it says?
خلاص استوى الحين صار reset all.
Okay, it says reset all. Press AC key. Okay.
Yes.
Now, in the second row, which are in green, you will find, starting from the left, simple, SMPL, compound, CMPD, cash, amortization, component, stat. What you want from this course, the two function here, compound and cash. CMPD and the cash. It depends on the problem that we are solving. If you press now compound, what did the first thing come to you? Or the title, what is the title at the top?
Compound interest.
Compound interest. CMPD bottom will give you that compound interest. What is the thing highlighted? شو اللي موجود عندكم highlighted now?
Set end.
Set end.
Set end. What we said in the first lecture, by default, our cash flows will be what? End of period. End of period. So make sure, always that to be set at end. Someone will say, okay, what will happen if I put it? Just press EXE and see what you are going to see. EXE. What you are seeing now?
Payment.
Begin or end. Always keep it end. Begin, it means this beginning of the period. And if you put it by mistake, it was beginning of the period, all your result will be different. You're going to get for another problems, another scenarios. So make sure always to have it end of period. Just press 2. End of period. Now, how much to put for N? Just scroll down. N, how much is it? 24.
24.
I?
8.
8 as it is. ما بأي واحد later on to say 0.08. No, leave it as it is. Why? Because what it shows there at the beginning it's I%. So put it I. How much is the P?
12,000.
12,000. مش موجود تحت الحين PMT. What is that PMT?
Annuity.
Annuity. We don't have any annuity here. What we have future value, or what we need is to find the future value, FV. If you reach to that one, want to solve, what to do? In the first row, to the right, blue bottom, just press solve. Tell me the answer.
minus 76094.
0.17. Why is negative? ليش negative؟ والجواب هنا كان عندنا positive. Why is negative? I'll tell you why. If you
Maybe
put
أنه
شلون لبنان؟
بيدفع. يمكن أنه بيدفعه.
لا. بس عشان الكالكوليتر ما له فصل، هو ما يدري انه بيدفع ولا بيستلم. With the compound, always calculating the equivalent. If you put the PV positive, it will give you the FV negative. Or if you put the PV negative, it will give you the FV positive. دائما يعطينا عكس الإشارة اللي خلينا في الفاليوز الثانية. Keep the sign for you. Don't stick to the sign comes from the calculator. Make sure with the compound, if you put it positive, copy the result as positive. بعيدها مرة ثانية. إذا خليته positive sign for the PV, don't worry about its sign that comes from result for the FV or for the MPMT. Make sure a sign to have it according to what you are going to put. خلينا 12,000 positive, yeah, we put it positive. So the answer is supposed to be positive. If you put it negative, we're going to get a negative sign. يعني الساين انت تتحكموا فيها، لا تخلي الكالكوليتر هو يتحكم. Later on we'll see what will happen if you're going to do it like that. إذا بتاخذون نفس الكالكوليتر بس الإشارة مال الكالكوليتر. Hope that's clear for the first part. واضح هذا ولا في أي سؤال عليه؟ Okay, no questions. Just to tell you that the participation is very important because I'm going to give marks for the participation overall and over the lectures for overall course. يعني مو بس على محاضرة واحدة ولا محاضرتين. Let's see the second example. Need you to work very fast now. An independent engineering consultant reviewed records and found that the cost of an office supplies varied. The cost of an office supplies high expenses. So we know it's downward. This is downward. If the engineer wants to know the equivalent value in year 10, equivalent value in year 10, which means what? Over 10 years. Over 10 years. Sorry. Starting from year 1, 0, 1, 2, 3, till the end. So you want to see the equivalent value, which is that F, for all that supplies. If the engineer want to know the equivalent value in year 10, for what? Or he's going to, what he doing for all of them? Only the three largest amount. Only the three largest amount. So the first largest amount, it's year 0, 600. Year 5, 400. And year 2, 300. make sure when you put them equivalent or relatively the length of the arrows now. The 600 did the longest one. Second one in year 5, 500. And in year 2, 300. LI 5%. Now, how to solve this? What is required from us is to find the F. How many standard notations we got to have? How many standard notations we are going to have?
Three.
3 standard notations. Thank you. So we can sum them up in one line. What we want to find? We want to find F. Let's do the standard notation for the first one. We want to shift it from time 0 to time 10. How many periods is that? 10 minus 0. How many periods?
10.
10 years. 10 periods. So what is the P in here? 600. Want to find the F? This P. Giving P. Notice here, this P at time what? Time 0. It doesn't matter. I'm not going to put 0 here. What is the I? 5%. Over how many periods? 10 periods. Plus, if you put here negative, so that one will be subtracting, minus. The second one, 300. Be given F. Sorry. Want to find that F, giving P, 5%. How many periods now? From 2, we want to shift it to time 10. So
8.
10 minus 2 is 8 years. Thank you. It's very important to do this because later on we'll see different type of calculation to find the periods for the other type of cash flows. So here 8. And the third one plus 500 F given P, 5%, shifting from year 5 to year 10. So 10 minus 5,
5.
5. That's the standard notation.
100.
No, 500 here. This is 500.
For Rasma.
Sorry, 400. Yes. We're taking that one. Thank you. $400. Now, if you want to solve it, you can use the calculator, a compound. Do it now. Give me the answer for the first one. Give me the answer for the second one. Give me the answer for the third one. Do it now, very fast.
First one,
First one is 977.3.
2 decimals, 77.34.
334.
Second one,
4.488.66.
0.66. Third one,
510.51.
now total. أخرنا شوي. Total. Let's add them together.
1976.5.
Sorry, how much?
1976.5.
2 decimals. Taha, 2 decimals.
151.
1976. 1976.5.
2 decimals, Taha. 1 decimals, it means you are going to lose marks. Point how much?
150. 47.
Okay. 5. تلفوا الحين. علي جواد، كان قلت شيء ثاني؟
طلع عندي 0.47.
على نفس الارقام اللي اخذتهم من هنا. Okay. Now, what we're doing, we are doing one by one. What we're doing, we are doing it one by one. With the compound, sorry, with the cash, we can put all the values. All what the data here, we can put it in there. Go to, again, clear everything very fast شباب. دقيقة واحدة إن شاء الله بنخلص. Go to الكاش.
دكتور
Put it in there.
الثاني طلع لي 433.
الحين بنشوف أي واحد أصح.
ما
Go to cash flow. I percent. How much is it? 5%. شنو تحت I? What do you have in there?
كاش وإديتور.
Editor. Press execute. It's going to open a column. Starting from 1. But what do we have here? We're starting from 0. So what is this? That's just the entry. Whatever entry you have. Whether you started from -1 or -2 or 0 or whatever, it will be the first entry according to what you have. Our first entry in here, this is at time 0. First entry, which is at time 0. Second entry at time 1. Third entry at time 3, at time 2, and so forth. So the values now, what to put? The first entry, negative 600, or just put 600. Because a sign exactly will give you the sign. If you put it negative, it will give you negative. If you put it positive, it will give you positive. The cash is different than the compound. Whatever sign you're going to put, why? Because it's going to do like a summation for all of them. A net value. Now put for the first entry, 600. Execute. Second entry, which is at time 1, how much we have?
175.
At time 1, well, how much we have in here? From the cash flow, how much we have? What cash flow do we have? Guys. Time 0, we have 600. Time 1, it is 0. We don't have any cash flow there. 0. Just look at your cash flow diagram. The first entry, second entry, third entry, fourth entry, fifth, sixth, seventh, 8, 9, 10, 11. This is all our entries. In year 0, which is our first entry in that cash, in that column, we put 600. Now, second entry, which is at time 1, how much is it?
0.
0. The third entry, which is at time 2,
300.
300. Fourth entry, which is at time 3, 0. The fifth entry, which is at year 4. How much is it?
0.
0. The sixth entry, which is at year 5.
400.
400. 7th, 8th, 9th, 10th, 11th. Entries. I'm talking about the entries. All of them are what? Zeros. Just put 0 for each one of them. So the shaded now will be with which entry? After you enter all of them. So 600.
11.
No, put 0 now. With the 11, you need to jump to entry number 12 to leave the shade in there, which means you have put the values up to year 11, or up to year 10, which is the 11th entry with 0. Make sure the 11th entry is there. Have you put 0 for 11th entry?
اوكي حطينا دكتور.
Okay. Now just press escape. Scroll down. Escape اللي هي solve. Scroll down. You will find net present value. If you want to calculate the net present value, you can do it from here. If you want to calculate the IRR, which is the internal rate of return, the payback, net future value. That's what's required from us in this problem. Just press execute or solve, will give you the answer.
على ال NFV.
NFV, yes. How much the answer?
1931.09.
So F here equal to 1931.09, which means you have a wrong answer in here. What you put in there, suppose both of them to have the same answer. وين الغلط صاير؟
الثاني 433 I think.
جواب 443 دكتور 0.24 الثانية.
433 point. So 2 decimals. Again and again, I'm mentioning 2 decimals. Point
443 دكتور.
443. Okay, 443 point how much?
24.
See the answer now.
Uh, 1931.05.
أنا جمعتهم بعدين هاي 4 3 here or 3 4 and that one 2 4 5 1. It gave me exactly the same answer at that one, which is 1931.09. Exactly the same answer. 977.34 plus 443.24 plus 510.51. Did the answer, which is the same as that one. Need you now, guys, to practice both of them to see how to use the compound, how to use the cash, to be fast in using them. Use the Excel to solve those two problems. Use the formulas. Practicing those later on to be, or you're going to be very fast in other or in using of the calculator. So we are done for today's lecture. Any questions, Shawab?